Hey everybody, welcome to projectmanagerhelper.com. For this demonstration, I'm going to show you how to do hypotheses testing using Excel as well as using the hypotheses testing lab in projectmanagerhelper.com, which in my opinion is a lot easier. So the first thing we need when doing hypotheses testing is we need a question or a problem that we're looking to answer statistically. So, hypothesis testing helps you as a project manager prove that your improvements for a project worked or they did not work, which means you can double down your efforts or throttle back and figure out a different approach. And you can do that using statistics. And it really helps you propose solutions to the leadership in your organizations. So, for this example, we have data taken at a doctor's office. We have the initial values, 150 observations of wait times, and then there was a process that a project manager attempted to improve by instituting certain measures. After a period of time, the measurements were taken again for wait times of the same number of days or patients, wherever it might be, and the average wait times were inputted in minutes. Now we know that the national benchmark for doctor's office wait time is 52 minutes, and we can use that to do t-test. If we had the standard deviation of the national benchmark of the general population, then we could also do z-test. So the two questions we're looking to answer in this example is question one: are the original patient wait times at this facility significantly higher than the national benchmark of 52 minutes? In question two, did the process improvement significantly reduce the average patient wait times compared to the original wait times? So to answer the first question, we're going to use a one sample t-test, which is when you know the measurements of certain data like wait times or profits, wherever it might be, and you know the average for the whole population. In this case, is a national average for all doctors' offices wait times. If you're talking about profits, it could be the average profit in your industry. The next thing we're going to do is formulate the null hypothesis, which says it is the status quo is true. So the average population of the doctor's office is equal to the national benchmark on average. And then we'll formulate the alternative hypotheses, H1, which says that the average of the original observations for the doctor's office is greater than the average population of the national mean. Now we're looking to reject the null hypotheses and therefore prove the alternate hypothesis is true. We could have additional alternate hypotheses as well. In this example, we just have one to test, and we're going to test it via a tailed one sample t-test. And then the second test we're going to do is a paired t-test before and after improvements. Those are useful for when you as a project manager improve the process, then another survey was conducted and you want to see if the benefits is either due to normal statistical variation or if it was actually due to the process improvement that you enacted. So the question is, did the process improvement significantly reduce average patient wait time compared to the original wait times? So the null hypothesis in this case is the status quo, meaning the mean of the improved is equal to the mean of the original. And the alternative hypothesis is the mean of the improved is less than the mean of the original, which means that wait times improved. We're looking to reject the null hypothesis in this case to prove statistically that the improvement that the project manager did actually helped reduce wait times. Here's the data. First, I'll show you how to do it in projectmanagerhelper.com because it's very easy, fast to do. So all you have to do is select the wait times in minutes and remember the national benchmark. Go over to projectmanagerhelper.com, find hypotheses testing. This is our hypothesis testing lab where you can do all sorts of t-tests, z-tests, ANOVA, and many more. paste the data that you just copied from Excel, and then just enter the variables here. So the national mean is 52, and we want to select a one sample t-test. The alpha, or the p-value for significance, we're looking at 0.05, which is the standard used in statistics. It could be different from this depending on where you're looking to test, but essentially this is saying that we can say that it is significant with a 95% confidence. Next, for the alternative hypotheses, we're looking to say that mean of the office observations are greater than the mean of the average population. So the average is 52. That's it. Run the test, and you can see here in the graph that the stat bar is within the red area, which means we can reject the null hypotheses based on the p-value being less than 0.05, which is the alpha. That means that we have proved using statistics that the results are statistically significant, therefore we reject the null hypotheses. Now you can open a report as well, and it has that all written down neatly here for a presentation if you're looking to do that. Now for the second question we're looking to answer, process improvement significantly reduced the average patient wait time compared to the original time. So for this one, we want to select both columns in Excel. We don't need the national benchmark because we're just comparing the before and after. And to do that, we want to do a 2 sample t-test. So select that. The alpha won't change, still 0.05. We can keep it at unequal variances. And then the alternative hypothesis says that the original wait time average is more than the second wait time average. And that's a right tilt test. We're looking at the right side under the curve for the second example. Run the test. Again, you can see the stat bar is way to the right. So again, the p-value is very, very small compared to the alpha of 0.05. So we have proven that there is a statistically significant change. Therefore, we reject the null hypotheses. And you can generate a report and use it to prove that the process that you enacted actually had a real impact, and it wasn't just due to normal variations in the data. And you can see here the mean wait times of the original versus after the improvements were made went down 6.5 minutes. However, you can know for sure without doing hypothesis testing if this was just due to normal variation or if it was actually statistically significant. A lot of times leaders will enact a change, have marginal results, and double down on that change, even though that change may just be a random variation and not actually tied in, not actually be caused by the change they made. That's why hypothesis testing is important. Now, as promised, I'll show you how to do it in Excel. So for the first example, we'll go to data analytics. You can download that ToolPak, just search data analytics and search, and you should be able to do that. We want to do unfortunately, there's no one t-test here, so we have to kind of trick the system to be able to do a one sample t-test. So select t-test 2 sample. Next, you want to select variable 1 range. So just drag down from A1 to A151. For variable 2, now we want to trick the system into just taking in the national benchmark 52. So we want to do the same, just select and drag down to 151. It will not work unless they are equal in length because they're paired. And then the alpha 0.05. We do have labels, so make sure we include that. And then we want the output here within the same sheet. Okay, now you can see here it didn't work because we have to drag this down to trick Excel into thinking we have a second set of observations. But numerically, this is going to be the same. So let's go ahead and try this again. Now it actually gives us the results because we tricked Excel into using the national benchmark, which Project Manager Helper does automatically using the one t-test. So here you can see again that the p-value is less than 0.05, which means that we again reject the null hypotheses and prove that our wait time is higher than the national average. And for that, we look at the one-tail results versus the two-tail results. For the next question, we wanted to compare the before and after. So that one will be a little bit easier. Data analytics, to sample, alpha stays the same. Instead of highlighting the C, we want to highlight the B columns since it has the before and after. And then the output. Here's the output for the second question, whether the wait time after the process improvement was enacted is statistically significant from before, and the p-value is 7.79 times 10 to the -6, so it has a bunch of zeros, which means it is way less than the alpha p-value, which is 0.05. Therefore, we reject the null hypotheses. With a 95% confidence, we can say that the process improvement, they reduced the wait time, so we should double down on those efforts. Now, another test we can do here is we can compare the new times with the national benchmark as well. So let's go ahead and do that as a final test. Therefore, we can recommend to the management or leadership in that office whether we should double down our efforts or what we've done is potentially enough to reduce wait time. There's also that cost benefit equation, right? So select t-test again. Now we want to compare the B column. We would like to compare that with the C column from C1 to 151. We want our output to be down here. Okay. So now we can look at the one-tail p-test. We can again reject the null hypotheses because it is less than 0.05. Now, if we want to know whether it got better or worse, all we have to do is just find the average. The average of B2 and B151. That is the new average patient wait time. And we already know that the average is 52 for the benchmark, which means that we proved that our process improvement is significantly lower than the national benchmark. Therefore, depending on what it may cost to do further improvements, we can recommend that the wait time is actually good and that could be used in marketing or anything like that for the business. Thank you very much for watching. Please visit projectmanagerhelper.com and explore all of our tools. Quick GWiz here. So the color coding in these cards means that they are linked together. So for the network advanced diagram, you can copy inputs from here into any of these for additional insights. Same, all the statistics are the same color. You can just paste data from Excel in all of these. Leave a comment and don't forget to subscribe for more. Thank you.